learners, welcome to the next session of quantum machine learning. Here we are going to discuss about what is quantum machine learning and what are the different kind of quantum machine learning strategies are there, and how the quantum machine learning algorithms to be very useful to cover all kind of limitation in classical machine learning and the performance. So in quantum machine learning, you know that we are going to compare with the quantum machine learning with the classical machine learning. In classical machine learning, we have classical bit. In quantum machine learning, or it may be quantum computing, we are having qubits. So we are having multiple states are there for each bit. And now we are going to discuss about how this ML algorithm and sub algorithm and classification task are to be implemented in quantum. So it is very useful to speed up all our application. In machine learning, data analysis is very useful to find out the patterns. As we already know that supervised learning is very useful to come out all kind of features, and for unsupervised learning is very useful for unknown data. Here we are going to learn how to transform the inputs into correct format. Now we may have a different kind of limitations are there. Sequential computing is very important in nowadays, but it is taking too much of resource consumption and time consuming. So space complexity is also there in sequential computing. So the data may be very large, means time taken for executing all kind of data sets is very important here. So ways of quantum computing can help how this classical computing limitation to be overcome here. QML can help with both kind of features. The first one is we can go with the fast linear algebra computation with the help of quantum speed up process. And also we can go with quantum basic linear algebra subroutines also. And Fourier transformers we can easily go with the QML. And finding eigenvectors and eigenvalues, everything is very easy in QML based algorithms, and we can easily solve the linear equation with a very fast manner. So exponential quantum speed up is there in all kind of quantum machine learning algorithms. So how this quantum computing is very useful in all kind of application means we are going to be implement all kind of parallel computation in quantum ML. High dimensionality data can be easily solved in qubits. Quantum machine learning can take time logarithmic in both size of the training set and a different kind of dimension of data. So classical algorithms for ML problems to be taken in the polynomial time in the size of training set and number of features. So exponential speed up with quantum algorithm is reached in all kind of QML. So this is the very important feature in quantum computing, why we are moving on to all kind of machine learning algorithm in quantum computing to handle all kind of high dimensional data. This quantum machine learning QML have different kind of strategies. So it is very important to meet all kind of quantum principles like superposition, entanglement and interface to enhance the learning process. Based on the origin of data, classical or quantum, and processing method, classical or quantum, we may have four strategies of integrating machine learning with quantum computing. In quantum machine learning strategies, we may have a four kind of strategies are there. The first one is CC, classical and classical. Next, we can consider the data as classical and quantum. And next, we can go with the third phase of quantum and classic. And the next, we are going with quantum and quantum. So this kind of approaches are very important to handle all kind of quantum computing strategies to solve the all complex task. Classical strategies, we can go with classical algorithm with the classical data set. Quantum classical, we can go with the classical algorithm processing with quantum data sets. Classical quantum CQ, we can go with the classical dataset processed on quantum hardware. Next is quantum algorithm with quantum dataset to be processed in this strategies. So in the case of classical processing, classical data with the classical processing, traditional machine learning algorithm are to be applied to data generated by the classical system. Example, image recognition and natural language processing. The key feature of here is here does not utilize any quantum computing. We are going with classical algorithm like neural network and support vector machine. Next, classical data with the quantum processing. Classical data is processed with the quantum algorithms to gain computational advantage. So here we may have a different kind of quantum based machine learnings are there. Quantum enhanced version of classical machine learning such as quantum support vector machine QSVM, variational quantum classifier VQC are there. Key features are requires special encoding the classical data into quantum state, because we are going to have a different kind of encoding mechanisms there, amplitude encoding and angle encoding. And the next key feature is target speed of in processing or model optimization. Quantum machine learning next approach is quantum data with the classical processing. Here data generated from quantum system is processed using classical machine learning methods. The example is analyzing results from quantum experiments or quantum simulation, understanding the entanglement or quantum state properties using classical ML tools. Here we are going to have a classical algorithm adapt to the unique properties of quantum data. This is very useful for understanding quantum systems without on quantum computer. And the next thing is quantum machine learning strategy QQ. Both the data and the processing occur in quantum domain. So full potential of quantum computing to be involved here. Here the best example is QNN, quantum neural network. The next thing is quantum generative adversarial network, QGAN. So here quantum properties like superposition and entanglement for both data and computation to be happen. The next thing is experimental challenges due to current quantum hardware limitation are also to be applied. So application future scope of this thing is CC and QQ strategies are very important for accelerating complex computation and achieve all kind of application like a drug discovery, cryptography, and high dimensional data analysis. QC strategies are very important for understanding quantum phenomena, feeding into advancement in quantum technology. And in the case of all kind of QML strategies are very important before entering into QML strategies. Thank you learners. We will see in the next session.